we're going to solve absolute value inequalities. We're going to start out with two kind of big rules. So the first rule, the first scenario, is going to be if the absolute value of x is less than a. We're going to have three different notations that this is going to become. Now we're going to show the three different notations. The first notation is called set builder notation, and it's going to be so it's going to be the set of all x's such that negative a is less than x is less than a. That's our set builder notation. Our graphing notation is going to be everything between negative a and a. Now we're going to have open circles, of course, because we are not including in this case. If it was an equals symbol with it as well, then we would have the solid circles, of course. Our interval notation, in this case we're not including the endpoints, is going to be from negative a to a. So this is our first scenario that we're going to get to. Our second scenario is going to be the opposite. What if the absolute value of a, x, is larger than a? And we need to keep in mind both the a's in both rules are going to have to initially be positive, because the absolute value always generates positive values when everything is said and done. So we need to kind of keep that in mind. The set builder notation here is going to be the set of all x's such that x is less than negative a, or x is larger than positive a. Again, keeping in mind that a is positive. Now to graph it, again, we're not going to include the endpoints in this case. So we're going to have nice open circles. But this time, the negative a is going off into the negative infinity direction. And after the positive a, it's going off to the right, to the positive infinity direction. Which means the interval notation is going to be from negative infinity to negative a, union with positive a to infinity. Again, everything's parentheses because we, for these generic examples, we are not including the endpoints. Otherwise, there would be brackets involved. But never with infinity. Infinity is always parentheses. Now, with both of these rules, we need to notice that when it's less than, we want everything included in between the two. When it's bigger than, it's the exact opposite. It's everything but the middle part. It's everything on the outside of that middle part. So they're exactly opposites of one another. So take a minute and kind of study these rules for a bit. We're going to go ahead and start the first example. We're going to start with the first scenario. The absolute value of x is less than 2. So, because it's less than, we're using rule number 1 up above, which means we're going to have everything included. So our answer in this case, in set builder notation, is a set of all x's such that negative 2 is less than x is less than 2. In interval notation, and we'll do graph notation as well. We'll show all three. Again, it's everything in between, with open circles, of course, because we are not including the 2 or the negative 2, but everything in between. Our interval notation is going to be open parenthesis, negative 2 to 2, because we're not including the endpoint. Well, let's do another example with the same type of scenario. However, the absolute value of x is going to be less than or equal, we'll say, to 3. Well, our set builder notation is going to be the set of all x's such that negative 3 less than or equal to x is less than or equal to positive 3. Our graphing notation, instead of open circles, we're going to have nice, solid, closed circles because we're including the endpoints in this case because of the equal symbol. And we want everything in between. Interval notation, we're going to have the closed brackets because this is indicating we're including everything between. Our next example, we're not going to graph this next example. We're going to have the absolute value of the letter B plus 1 is less than 3. Notice we're still on the first scenario with the rules. We have the less than there. So this is going to become negative 3 is less than B plus 1 is less than positive 3. Now I need to solve for the B in the middle by subtracting a 1. Remember, you need to subtract the 1 from everybody. All three pieces. Giving me negative 4 is less than B is less than 2. And I'll let you fill in the other notations. Our next example is going to be the absolute value of x minus 2 is less than or equal to 1. Alright, so what we're going to do now is we're going to break it down into negative 1 is less than or equal to x minus 2 is less than or equal to positive 1. And now to get the x by itself, I'm going to add a 2 to everybody. Giving me 1 is less than or equal to x is less than or equal to 3. Now let's write down all three notations. We'll start with set builder notation. Set builder notation is going to be the set of all x's such that 1 is less than or equal to x is less than or equal to 3. The graphing notation is going to go from 1 to 3. Now we're going to include the endpoints. We're going to have nice solid closed dots to everything in between when we have less than situation. Interval notation, we are including the endpoints 1 and 3, so we are going to have nice closed brackets. Make sure that you read the directions on either your homework or from your teacher because it's really going to matter which notation you write your answer in. They may ask for one of them, they may ask for all three of them, they may ask for two of them, it just depends. One more example of this type. Absolute value of 3x minus 2 plus 5 is less than or equal to 9. Now the rule says I have to have the absolute value by itself. So I'm going to go ahead and subtract a 5 from both sides. Absolute value of 3x minus 2 is less than or equal to 4. Now I'm going to break it into its pieces. I'm going to have negative 4 is less than or equal to 3x minus 2 is less than or equal to positive 4. Now I'm going to isolate the x by adding a 2 to all three pieces. Here I have 3x in the middle, negative 2, less than or equal to 3x, less than or equal to 6. And now I'm going to divide through by 3. Remember, everybody gets divided through. So now I have negative 2/3 less than or equal to x, less than or equal to 2. And let's write out our three notations. Our set builder notation, set of all x's such that negative 2/3 less than or equal to x, less than or equal to 2. Our graphing notation, now negative 2/3 is going to be between negative 1 and 0. It's going to be about 2/3 of the way there. We're going to have a right here. This is going to be our negative 2/3. And here we have our 2, and we're going to include both, so we're going to have solid dots, because we have the equal symbol there, and it's everything in between. And finally, our last notation is going to be closed bracket, negative 2/3 up to 2, and we are including closed brackets for both because we are including endpoints. We're now going to move on to the second type from the rule. If you look back a couple of pages, this first example is going to be the absolute value of x is bigger than or equal to 3. So this is opposite of what we've been doing. This is going to give us a couple of different scenarios. It's going to give us, first off, that x is bigger than or equal to 3. Or x is less than or equal to negative 3. Now there's a reason for all this. We're actually ending up dividing by a negative number at one point, which is why the signs switch. But we have to be really careful how we write our answers. We'll start out with the set builder notation. Set of all x's such that x is bigger than or equal to 3, or x is less than or equal to negative 3. The graphing notation is going to be the opposite of the previous ones that we've been doing. I'm going to include 3 and negative 3 because we have solid dots because of the equal symbols. But instead of everything in between, it's going to be the opposite. It's going to be everything going in the opposite directions. Everything bigger than 3 and less than negative 3. We get this no man's land thing going in between there. Our interval notation, we're going to have to use the union symbols. It's going to be negative infinity to negative 3, union with 3 off to infinity. Notice I have the closed brackets for the 3, but infinity always has parentheses with it. Let's try 2 more examples. Next example, absolute value, y plus 4 is bigger than or equal to 6. Now in this case, again, we're going to have y plus 4 is bigger than or equal to 6, or y plus 4 is less than or equal to negative 6. Now I have 2 inequalities that I'm going to have to solve. I'm going to subtract 4, giving me y is bigger than or equal to 2, or, subtracting 4 again, y is less than or equal to negative 10. Set builder notation, the set of all y's such that y is bigger than or equal to 2, or y is less than or equal to negative 10. The graph notation, notice I had to label this one y. A lot of the other ones are labeled x, because we're dealing with x. In this case, we're dealing with y. So at 2 and at negative 10, I'm going to have nice solid dots because we have the equal symbol. And because it started out as a greater than problem, it's actually going to go off to positive infinity and off to negative infinity, giving us this no man's land in between and everything on the outside opposite. Interval notation is going to go from negative infinity up to negative 10. We are including the endpoint, so we have a closed bracket. Union with closed bracket 2 up to infinity. Our last example is going to involve some fractions. We'll be okay. Absolute value of x over 5 minus 3, closed absolute value, minus 8 is greater than or equal to negative 4. All right. Again, the rule says I have to have the absolute value by itself first. So I'm going to go ahead and add an 8 to both sides, giving me the absolute value of x over 5 minus 3 is bigger than or equal to 4. I'm glad it changed it to a positive. If that was a negative, we'd have some problems. So now it's going to break into the 2 scenarios. I have x over 5 minus 3 is bigger than or equal to 4, or x over 5 minus 3 is less than or equal to negative 4. And now I have to solve each inequality. I'm going to add 3 here. X over 5 is bigger than or equal to 7. Multiplying both sides by a positive 5, so I don't have to switch the inequality, I get x is bigger than or equal to 35. The other inequality, I'm going to add a 3. X over 5 is less than or equal to negative 1. Multiplying through by a positive 5, I still won't switch the inequality. It's going to be x is less than or equal to negative 5. So, our notations, we'll start with our set builder, is going to be the set of all x's such that x is bigger than or equal to 35, or x is less than or equal to negative 5. Our graph is going to have everything less than negative 5 and bigger than 35. We're just going to scale this down here just for simplicity's sake. Again, we have solid circles because we're including those endpoints. But now instead of everything inside, it's going to be everything opposite of the inside. It's going to be everything on the outside. Again, creating that no man's land. And lastly, our interval notation is going to go from negative infinity up to negative 5 with a bracket because we're including negative 5, unioned with 35 up to infinity. Don't forget the brackets on the numbers in this case and the parentheses for the infinities in this case. And there you have it.